All right, one of the first things we're going to look at here is distance and displacement and the difference between the two. I'm going to illustrate this with an example here. If we think of distance, okay, well actually first we'll think of 2 points. So imagine I just had 2 points here, I don't know, make one point A, the other one point B. Now to get from point A to point B, I might take a variety of paths. And maybe I choose this one. Maybe I choose from point A, I kind of walk around here, and I finally get to point B. The distance that I traveled would be this exact measurement represented by the black line. It would just be, if I added up all of this distance, that would represent my distance in meters. In other words, think of this as a string, and if I pulled the string, I could measure this entire path length. Okay, that would be my distance. My displacement, though, I'm going to represent it with this orange line, and it's basically a straight line from point A to point B. In other words, here's the difference you consider in path from point A to point B, and it's actually a vector, so it has to have direction. In other words, I traveled in this direction to get to point B, and I'm ultimately this far away from where I started from. This would be your displacement. Sometimes displacement is represented with a little arrow, and D would be for distance. So D with an arrow would be for displacement, D is for distance. This would be essentially the difference between distance and displacement. Could the distance ever equal the displacement? Absolutely. If I traveled only in a straight line, in other words, let's say there's point A, there's point B, and I went and traveled from point A to point B in a straight line, my distance would equal my displacement. So it's possible for them to equal each other in magnitude. However, they do mean different things because the displacement would still include the direction. I guess in this case it would be to the right. Okay? So it still include the direction. They do mean separate things, but the magnitude could be the same. Another confusing concept is sometimes called speed and velocity. Now most people have an understanding of what speed is, but velocity is a little bit different because they're not used to dealing with it in everyday life. The equations for the two are relatively the same, and they look like this. Essentially, V is equal to D over T. In this case, V would represent the speed. Okay? V would represent the speed. This would be distance, and this is time. So in this case, that's speed, that's distance, and of course that's time. But if you look at the velocity equation, it looks almost identical. I'm going to draw with a little arrow to represent velocity. That's going to equal D with an arrow over time. You'll know now that this represents displacement. Okay, so this will be displacement, and this is velocity. They look relatively the same. What's the fundamental difference between them besides what they're based on? Well, velocity again is a vector. It has direction. Speed does not. And so if I look at this, I'll take a moment here and try to illustrate this with a circular example. You can imagine here that I have a circular track. And here's my circular track. And there's this car that's going to be traveling around it. And this car can travel around it and go in this direction. As it travels around her, suppose it traveled at a constant speed of 20 kilometers per hour. This constant speed traveling around the track would be 20 kilometers an hour. That's no problem, except that it is changing velocity. And the reason it's changing velocity is because the entire time, if I represent the arrow here with a marker, it'll be changing direction. Even though it's moving at a constant speed, it is changing direction, and as a result, changing velocity. Okay, that being said, the fact that it is changing velocity, means something else, and we'll get to that in just a moment. The average velocity is something a little bit different, and this gets into one other thing about instantaneous versus average and what they mean. And if I take a look at this previous example here, about the average velocity or the instantaneous, at any given moment, the instantaneous speed will be 20 kilometers an hour. the instantaneous velocity will be 20 kilometers an hour in the given direction. It could be down, it could be to the left, it could be up, it could be at some angle, but it'll be in any given direction. Average is a little bit different. And if I'm going to calculate the average, okay, I'll represent that with a bar. If I'm going to calculate the average, if I'm going to calculate the average speed, I would need to find the total distance over the total time. In other words, I would take the circumference of this if I want to find the average speed when I'm going around once. How far did it travel? Divided by how much time it took. If I want to find the instantaneous velocity, I could do it just again from looking at this. But the average velocity would be taking the total displacement. Okay, the total displacement over the total time. Okay, the total displacement over the total time. And in which case this one would represent the average velocity. Well, if you look at this example that I've drawn up here, the the average velocity in this case would be 0 if I calculate it going once around the track. The reason being is because if a car went all the way around this track, it would have a displacement of 0, in which case this would be a 0 average velocity. However, even though it has a 0 average velocity, it still has a numerical answer for the average speed, because the distance traveled is not 0. Okay, it's the circumference of the circle. So there are differences between speed and velocity. Besides just a notation, it is a fundamental difference, and one is a vector and one is not.